All right, so I did a video where I started the engine, and it seems like it's going to be okay with no harm done from the block freezing. However, the test stand fan wasn't working, so I'm going to work on that now, and I'm going to show you what I'm going to do to try to diagnose what's up with the fan. Only a few options really as far as what could be wrong, so let's figure it out. All right, so it's an electric fan. The way I had it set up was you turn on the master switch for the power, right? And then I had one switch that was for ignition, fuel, gauges, you know, kind of ignition on, kind of the auxiliary position or on position, I guess it would be on your key if you were in a car with a key. Then fan enable. I had another toggle switch here to turn the fan on, and it had a separate relay to send, 12 volts to the fan. Originally in the loop was the rheostat that was in the intake manifold, so the fan would only turn on and off when it was actually needed. The old intake manifold that I took off, the position for a second, thermostat or coolant temperature sensor wasn't accessible. So I just ended up hardwiring this. So yeah, you have the switch for on and off, but there's no coolant sensor in the loop there. So it's just on or off with a relay still. Because the switch, the ampage draw for the switch wouldn't be good to have in the loop with the ampage draw for the fan, because you'll burn your switch up. So two things are possible. One would be the relay's bad, and the other would be the fan's bad. I guess there is a third thing. The wiring could be screwed up. Although it worked, right? And then it shut off. So I guess a vibration could have, broken an electrical connection. But we're gonna go after the first two things first. And I'll show you what I'm doing, but then I'll speed up the camera or just skip past it and tell you the result. First, I'm gonna check the electric fan. There's a connector here, heavy duty wire, sends 12 volt and ground to the fan motor. I'm gonna break this connection right here. There's a couple spade connectors, and then I'm gonna just use a couple of wires with spade connectors and just hook it right to the battery and see if the fan comes on. Piece of cake, other than having to do the work. So I'm gonna do that now. All right, so I've got a jumper wire, a couple of jumper wires on here to the spade connectors. So that's the wire from the fan for 12 volts. There's a couple of spade connectors on the hard shell there. One I've got going to ground. The other I'm gonna hook up to battery positive, and we'll see what happens. Fan should turn on as long as the fan is good. So, yeah, we got fan. Spin it away. So it's not the fan. Fan is not the problem. All right, now that we know it's not the fan and that the fan is good when it has 12 volts to it, I'm gonna put that all back together the way it was. And we're gonna dig into the wiring from the relay. We'll look at the relay first, I guess, and then we'll look at the wiring in the relay. All right, so the fan works. Let's check the relay. So 85 and 86, the two pins on either the left or right side, vertical, I hope you can read those numbers. Those connect a coil. That coil actuates a switch that goes between, in this 5-pin model, 87 or 87A. I think 87 is normally open, so when you actuate the switch, 87 becomes closed. So 87 and 30 then connect. When you're not actuated, your pin in the middle there, 87A, is actuated. So it's normally closed. 87 is normally open, 87 is normally closed. Then when you apply voltage to the coil between 85 and 86, the switch throws and 87 becomes, let's say, hot, because I got 12 volts going in on pin 30, and it's either going to go to 87 or 87A. So when I want it to go to 87 and turn the fan on, I have to throw 12 volts across to 86 and 85 there. So we're going to check this coil. First you check the coil, right? Needs to have some resistance across that coil, something north of 50 ohms, really less than 200 they say, but I've never seen that. But let's check this thing and then we'll see if it's switching. So let's check the coil first. All right, so I got my voltmeter set to ohms. I got one side on, what, 85, and I'm gonna connect to 86 here, and we'll see what the resistance is. Get good connection there. Come on, you can do it. There we go. Yep, 79 ohms or so. Perfectly fine, no big deal. All right, so it's not the coil. Now we're going to check to see if this relay is switching. And you can do that by applying a small voltage between 85 and 86 and see if you hear it click for this the switch of connecting 87 to 30 instead of 87A. In fact, let's go ahead and check. It should be, what, 30 and 87A for normally closed. Sure enough, there you go. Zero ohms for the normally closed. The normally open better be open. Yep, sure enough. Go up to 87, nothing. If I apply a small voltage between the two pins for the coil, it's going to switch around, or at least it better, 87 and 87A. All right, I'm going to be super quiet here. And let's see if we can hear this thing click. Yeah, it's clicking. So that coil's good, which means if I go back over here to the bench, there's the, there it is. There's the fan relay housing. Either there's something wrong with my switch, which is buried way down in there, or something wrong with the wiring in the back of this fan relay. Something must have vibrated shut. Must have vibrated off or something. I don't know. But I'm gonna stop filming for a minute, take a few things apart so I can get to it, and then we'll go from there. Okay, so sort of good news. I figured it out. So the fan's not bad, the relay's not bad, the wiring on the back of the relay's not bad, the wiring to the switch is not bad. What is bad is a circuit breaker. I put a circuit breaker underneath this test stand, and I don't know if it got damaged with the water, the coolant, the water that was in the engine froze and all drained out, and it drained onto this pan. I'm going to show you the top view, then I'm going to show you the bottom view. All right, top view. So there was the freeze plug that drained out. You can see rust stains, water collected on this pan, this tray that holds the battery and the fuel tank, and I mounted a bunch of electrical stuff to this guy. Go around the other side so you can see it. There you go. I got a master switch, and underneath here I've got the starter relay and a few other things. I'm going to flip the camera around and show you. All right, so bear with me. You're going under the engine test stand. All right, so there's the switch, the master electrical switch for the test stand. There's the starter relay for the engine setup. Over here I've got two circuit breakers. Let's see if I can point. This one seems fine. This one is not fine. It doesn't seem to be working. Now I got to figure out what to do. The wire that goes to the fan is that one right there. So I think for now what I'm going to do, yeah. So remember when I had the jumpers on there and I just hardwired it to the battery and the fan was running? That worked. I think that I'm going to push the engine out in the driveway. Push the engine stand out into the driveway, I should say, the test stand. And I'll just hook up the fan using that method. And at least then I'll have the fan working for the period of time that the engine is running. I really don't need to run it for that much longer. I want to set idle speeds. I want to crank timing back a couple of degrees at idle. Not a lot to do. Probably heat cycle the engine a couple of times just to make sure I don't have any leaks, given that the thing froze. Yeah, sounds like a day's worth of work. It's Father's Day. It's going on. Oh, happy Father's Day to any other dads out there. So Father's Day, 4 o'clock in the afternoon. I think that I might be done for the day because, my family's got some Father's Day stuff going on for me today. But at least I know now I know what's going on. I'm going to fix here. Let me show you. So to get the relay off of the test stand to look at the wiring and everything, I did lower the radiator support. Just that guy there. I'm gonna put this all back the way it was, button it up. But then I'm probably gonna call it a day for today now that I know what's going on. Then I can fix it, start the engine up, do what I need to do. And then when it's cooled all down, it's time to take the engine off of this test stand and we can put on the flywheel, the clutch assembly, put the bell housing back on there and put the trans on, figure out the whole hydraulic clutch and start thinking about dropping it in the car. Hey, yeah, I'm making progress. At least I feel like I'm making progress, figuring out what's wrong, figuring out what I can do to get around it. And here we go. All right, I'll see you probably tomorrow. Maybe when I get home from work, I will push this thing out as long as it's not raining.